Welcome to this section of the Algebra Word Problem Tutor, where we're going to have word problems that deal with speed and distance and time. These kinds of problems are the ones that I know you've all seen before, where you'll have train A leaves a station at this time, and train B leaves a station at this time, and they're going at a certain speed, and how long does it take them to reach, or how long does it take them to overtake one another, or whatever. There's lots of different variations on this kind of problem, but they all involve distance somehow and speed and time, okay? In every sentence, and try to translate it to the algebra. Two planes leave an airport and fly in opposite directions. Okay, one plane flies at 125 miles per hour, and the other plane flies at 75 miles per hour. How long will it take them to be 500 miles apart? Okay, so here's an airport, right where my finger is. One airplane goes this way, one airplane goes this way, and they go at different speeds, okay? One going at 125 miles an hour, one going at 75 miles an hour. And the question is, how long does it take, so how many hours does it take for them to be a certain distance apart, 500 miles apart? So let's draw a picture. Here's your runway for your airport. Okay, miles, that's when we stop the stopwatch and we say, okay, that's long enough. That's what we're trying to find, okay? So the distance that this plane travels is going to be 125 times the time traveled, okay? Now think about that for a second. That's why I put this up here. Distance is speed times time, right? The distance this plane travels, this is the distance plane A travels in time t, which we don't know. That's what we're trying to solve for. How long does it take, okay? But we know that after a certain number of hours, this plane will travel this far, 125 times t, speed times time, okay? Plus, how long does this one travel? How far from before, and I'm going to write it down over here, that distance is speed times time, speed times time. We've already established that from before, okay? So we're going to use that. We know that they're 200 miles apart, okay? So, if speed of person A times time plus the speed of person B times time, this is the distance person A traveled going this way, and this is the distance person B traveled going the other way. When the total of those two things add up to 200 miles traveled, then they have by definition met in the middle. These are the kinds of things you'll have to get the hang of translating in your problems, okay? When they meet, okay, that means the total distance has been traversed. The distance is, and the other problems was kind of constraining things. It was like the other problems with the two people walking apart, and finally they get so many miles apart, and that's telling you that you're writing an equation in terms of distance because they get so far apart. In this problem, I'm driving at a certain speed, I'm walking at a different speed. Okay, the constraint, or the thing that ties it all together, okay, is that the total round trip time is 1.25 hours. That's important because it tells me that I'm going to be dealing with time, okay? This is how long it takes the entire thing to happen, okay? So, writing it down, the time of the walking, let me write it this way. The time that I was on the bike plus the time that I speed times time, okay? Now, the clock starts. Car leaves, then the bike continues traveling, okay, at some distance, and the car is traveling at some distance, okay? This is distance bike travels after car leaves. Okay, and this is just the distance car travels. Okay. So bike gets a head start, goes down the road certain distance in 1 hour, okay? Bike continues gaining ground after the car leaves, and the t is